All right, honors, probability, and stats. This is chapter 7, section 2. We're going to deal with standard units and areas under a standard normal distribution. Okay, so it's very much like 7.2, just going to switch up the values. Okay, so let's get here. Basically, if you're going to be given mu and sigma, the mean and the standard deviation, we're going to be able to convert raw data to z-scores. So there's a formula there. All right. If you have the mu and sigma, we'll be able to convert a z-score to raw data. So it's basically the inverse operation. And then we're going to graph the standard normal distribution, and we're going to find an area under the standard normal curve. And that comes from a chart, a table that you all will be given. So here's the formula for the converting mean, standard deviation, and a raw score to a standard value, which we call a z-score. Z is equal to the raw data, that's your data piece, minus the mean, which is given to you, divided by the standard deviation. Okay, that'll give us our z-score, which is called a standard score. Okay, it's going to be a number usually between 3 and -3. It can be a little bit larger than 3. It can be a little bit smaller than -3, though. Okay, this first example on how to find the actual z-score. It says, a pizza parlor franchise specifies that the average mean amount of cheese on a large pizza should be 8 ounces. So there's our mean. Mean is 8 ounces. And a standard deviation of 0.5 ounces. Sigma is equal to 0.5. An inspector picks out a large pizza at random, and one of the pizza parlors finds out that it's made with 6.9 ounces of cheese. Assume the amount of cheese on any pizza follows a normal distribution. If the amount of cheese is below the mean by more than 3 standard deviations, the parlor will be in danger of losing its franchise. So they want to make sure they're putting enough cheese on it. So here we go. Z is equal to the 6.9 take away 8 divided by 0.5. X was our raw data, our mean, and our standard deviation. In doing the computations, we get a -2.2. All right, so it's not more than 3 standard deviations below the mean. All right, and I'll explain the standard deviations above and below in 1 second. So I want to go back to this pizza problem. If I draw a standard normal curve, we know that smack dead in the middle, the mean is 0. You know, this is -1, this is -2, this is -3. +1, +2, +3. Where does -2.2 land? Well, if this is -2, -2.2 is right here. Now, we need to find the area under the curve. That's our next step. The area under the curve, when I'm giving you a chart, I'm going to give you a standard normal chart, a standard normal table. It's going to give you the area to the left of whichever z-score you have. Always the area to the left. Okay, you need to memorize that. So this is how they're going to get our standard deviations. The standard normal distribution is a normal distribution with a mean of 0 and a standard deviation of 1. So take a look at this figure. In chapter 7.1, we had the raw data in these particular spots. Okay, so what's going to change is on a standard normal, it's going to have a mean of 0. So remember, the mean is in the middle right here, mean of 0. And we're going to add 1, we're going to add 1, and add 1. So that's going to give us our 1, 2, and 3 standard deviations above the mean. Subtracting 1, subtracting 1, and subtracting 1 will give us our 3 standard deviations below the mean. So these numbers here are your z-scores, okay? The empirical rule still applies. There's still 68% of the data between 1 standard deviation above and below. 95% is between 2 standard deviations above and below. And 99.7 is the amount of data, or the percent of data, that's between 3 standard deviations above and below the mean, okay? So this is where we're going to get to standardize the raw value, okay? So we kind of look at this example. Find the area under the standard normal curve to the left of a z-score that is negative 1.00. And you'll see that all z-scores go to 2 decimal places. So according to what I showed you, you know that this is the mean, so negative 1 appears right here. So we're looking for the area right here in the green. The area to the left is this area right here is 0.1587 was. So basically 15.87% of the data will fall to the left of a standard value of negative 1.0. Now remember, underneath the entire curve, there's 100% of the data. All right, so we're still using that concept. Because if we had to find what's to the right of it, which is our next example, oops. So as I was saying, if the area to the left, this green, is 0.1587, if I changed one thing in this problem, and I changed this word left to right, I want the area to the right of the z-score of negative 1.00, meaning I want this purple area. Well, if you still look up the chart, and remember, the chart always gives you what's to the left, always. And you know that 100% of the data is underneath the curve. Therefore, to find the area to the right, it's simply 1 minus the area to the left. So therefore, the area to the right is 0.8413. So you actually commit that to memory. In using the chart, if you look to the left, or excuse me, if the question is find the area to the left, whatever you look up on the chart is your answer. If the question is find the area to the right, you still look up the area to the left, but you have to subtract it from 1 to get the area to the right. Let me see. Oops, there it was. So your z-score table is going to look something like this. In one of the columns, it's either the column to the right or to the left, you'll see a 1-digit number. And then in the top, you'll see a 2-digit number, 0.01, 0.02, all the way to 0.09. You kind of put it together. So if I'm looking up negative 1.00, I find the negative 0.1, which is this portion of it. And then I find the 00, because it has to end in a 0. And I kind of follow to the right and down, and I will see a 4-digit number, 0.1587. So what that means, see? So negative 1 was the 1587. Here's another one. Let's find the area to the left of a z-score of 1.18. Therefore, this percentage is 0.8810. That's the area under the curve. That is the percent of data to the left of that 1.18. And if I change this to the word right, which is this area, you still look up 1.18, you still get the 8810, but since it's to the right, it's going to be 1 minus the 8810, which is 0.1190. That is the area to the right of a z-score of 1.18. So you guys can 15. So on the chart, we look for 1.1. And then up top, we look for the 08, which is right here. And then you kind of just move to the right and move down. And the number you see is 8810. Go back to D7. The other area was the 8810. That's for the 1.18. So here's the rules. Number 1. For areas to the left of a specified z-value, use the table entry directly, just like I said in that previous example. Number 2, for areas to the right of a specified z-value, look up the entry for z and subtract from 1. Hopefully I explained that well. And then this one, we'll take a look here now. For areas between two different z-values, z1 and z2, one of them has to be larger than the other. In this case, z2 is larger than z1. You're going to subtract the area for z1 from z2. So basically, it's going to be large minus small. We're going to create areas underneath, to the left, to the right, and in between. All right, we're good to go. Just want to talk about the table, these two little rules. Any area to the left, i.e. smaller than a negative 3.49, has an area of 0. Any area greater than 3.49, this is your z-score, will have a 100% chance of happening. Okay, so those are kind of your break-off points. So while we're here, let's talk about the in-between. Okay, so let's use the same values that we had before so we don't have to look up anything else. Okay, so we had a z-score before of, let me go back and look, let me pause it. So we had a z-score of a negative 1.0 in that first example, and then we had a z-score of the 1.18, okay? So I do want to draw a little picture just so you guys can see. So if I draw a picture of this, here's my standard normal curve. Negative 1 is about right here. Positive 1.18 is about right here. Just guessing. So when I look up the larger z-score, it's going to give me the area to the left of him, all of this. When I look up the area of negative 1, it's going to give me this area to the left of that. Well, if you think about it, I want the area that's in between, right? I'm doing that third example. Left, you use the chart and write the answer. To the right, you use the chart and subtract from 1. And now I'm showing you the in-between. So if you take the green area and you chop off, i.e. subtract the small area, it'll give you the area that's in between. And that's exactly what we're going to do. So the percentage that was below the negative 1, so the area below here is 0.1587. That's to the left of that negative 1. 10. So the area below this guy is 0.8810. Therefore, the area in between is always going to be large minus small. So that is 0.7223. So the area of this green shaded in between where this red star is 72.23%. Okay, and that's pretty much everything in 7.2. How to read the chart, how to find a z-score by taking raw data minus the mean divided by the standard deviation, and then the three different